Hello everybody. My name is Oren. I'm a senior product manager at Checkpoint, located in Israel in the headquarters. I'm an Army veteran. I've led for 13 years cybersecurity development in the Army. Let's put it aside for a second. I founded multiple startups related to data mining and machine learning. And I'm working at Checkpoint for 4 years, focusing on threat analysis and threat hunting of threats in customer networks. In the last almost 4 years, I've conducted more than 200 SOC operations hands-on boot camps. That means I've sat with those operators. I will explain what are those in a second. And I've trained them. And I've learned a lot about the methodologies of how do we analyze a threat in our network, endpoint, mobile, cloud, and how we can maybe, just maybe, automate it. So everything starts with a story. So let's start with a story, a real one in this case, that we've encountered that will assist us to understand what is the challenge that we try to solve. So European bank, 5,000 employees, 1.1 billion revenue, and 2 security operations in the SOC operation. Now, what is a SOC operation? Security Operations Center is a room, is a team that are responsible to review, of course, with other areas, but focusing on this presentation, review the logs and the connections and the traffic and the data that is created in the network itself, trying to look for threats that got inside. When we try to attack a bank, there is an asset the bank wants to protect on. That will be our money, right? So the bank is putting lots of boundaries and lots of areas of control on this asset. And the SOC needs to analyze the data comes from those boundaries or locations, saying there is a real threat, there is not a threat, or to verify that no one hacks basically the bank network in this case. Now in this case, it was a challenging one because they got hacked. Basically, they got Ryuk. Ryuk is a pretty bad ransomware with 500 critical systems that are down and 3 branches that are completely paralyzed. Now, to understand how does the analyst work, we need to look at the flow of the attack in this case. And the flow of the attack was pretty simple. Someone got an email. This email got attached with a malicious file. He clicked or opened this malicious file, installed a malware on his host, and then lateral movement in the network. Eventually, after a long period of time, Ryuk ransomware. And what is Ryuk ransomware? TrickBot, think about it as a baseline application that you install, and above that you have modules that you can buy. So I can buy TrickBot, I can buy Ryuk. Those are 2 different things, and I can combine them. TrickBot will allow me to lateral movements and to do lots of bad stuff. And Ryuk, functionality of Ryuk, will allow me to ransom those hosts. And there is a question behind it, because there is a SOC. There are the 2 personals in this bank case that are responsible to analyze the data, to monitor the threats, and to find those threats inside and outside. So how did they miss it? Now, when I will jump in to the machine learning side and how did we done that, remember the following slide, because those are the business questions or the customer questions, or basically those are the challenges we need to solve. And the first challenge is the fact that a SOC operation in any organization you will ask have thousands and tens of thousands of alerts every day. An alert can be a malicious connection that has been seen, a malicious file that has been downloaded, a server has been attacked. But there are only 2 personnel. So how do you know to differentiate? How do you know to locate the most important ones first? But the second part is, how do you differentiate with the ones who are false positive and the ones who are not? A SOC operation have lots of goose chase at his flow. I can analyze as a SOC operator in an organization for 3 days a threat. And it's just a goose chase. I finished with nothing. But there are only 2 or 5 personnel. In those 2 days, I could have analyzed lots of other stuff. if I would just have known this is a false positive. And the third, and from a big data perspective, I assume some of you or most of you know that better than me. The SOC operation need to collect the data from multiple sources. Think about the deployment of a bank. They have an endpoint solution from security perspective and compliance perspective. They have a gateway, they have a proxy, they have lots and lots and lots of technologies. Each technology speaks in a different language. They need to combine it into one place, and after they combine it, it's not thousands of alerts, it's millions of alerts, because it's a combination between all of those pieces in the same place. So to understand that, let's get just a number. And if we take a 2,000 users network, in one day, they will have, in a simple deployment of a firewall, the simplest that there is in the world, they will get 10 million logs, 10 million events or samples that are not tagged, that are practically logs that they can add into any kind of a system. It can be a Kibana, it can be Splunk, QRadar, ArcSight. It can be any kind of a SIEM solution that will correlate everything, or we just put everything inside. But how do they, or how can they locate the threats inside this enormous amount of logs? And that's the question we try to answer with the machine learning side. Now, when we will focus looking forward on how we've done that, remember the following. The user have lots of knowledge. There are so many SOC operations in the globe, and they know a lot. The question is, how do you combine their story into one area of knowledge that can give a really precise answer? Now, I'm starting from the end, precision. When we look at what we've created, and in a second I will jump in and explain everything inside, 59 million logs from endpoint, network, cloud, mobile, IoT, any attack vector that can be used by an attacker against the network or on the network, but eventually 11 infected assets or infected devices, depends. So how do we find those 11? That's the question. How do I take this data set, or all the data sets I have, and really focus the alert or the insight into a meaningful thing? Or more important, into a precise alert that will allow the SOC operator to find these important things inside his lot of logs. So how do you start, or how did we start the process of machine learning project that try to solve what you've just seen? One is to pick a name, and the name we've chosen is Maggie. You can Google it. You can look for it. A good series, I will say, a very niche and behind the scenes character, but a very powerful one. Because of that, we've chose Maggie as the name. Second, get a mathematic resource. You don't need to have those to of course, be a great mathematician, and not all of the team have that. But we have the resources in Checkpoint. We know how to do it. The challenge is if you have the experts, and that's also what we have. So we have the experts that can tell us exactly what is a threat, exactly what needed to be taken care of, or train the mathematician team with what is needed to create an algorithm. But eventually, what you need and what we have and we had for this project is lots and lots of data. And we will talk about that in a few slides, how much data we have. So let's understand the curse of the cyber machine learning from our perspective for this specific algorithm called Maggie that is focused on the SOC challenge. Locate the top threat you need to take care of. And now let's understand how. We've started with a supervised machine learning model. It requires lots and lots and lots of level data. Now, labeled samples are pretty expensive. That means investigation time that we will need to do, and lots of money we need to put on that, and that's a lot. So we took a different approach. we built an initial model with a sample set, basically a ground truth. Now, to understand the ground truth, you need to understand how an analyst thinks, or you need to have enough analysts that knows how to analyze, because the expert, that is the analyst, need to come with the data and tell the mathematician team or the mathematician owner side, this is how I work. Those are the features I am using to analyze this threat, and this is what I know. Definitely infected or definitely not. We'll talk about in a second how we've done that. Now, we need to report infections to a customer, and that's the second powerful part in Checkpoint case. We have tens of thousands of customers that can be contacted. This is our baseline of cybersecurity. We have an enormous amount of customers. And if they can say true or false, that would be great. And eventually, after getting a feedback loop or getting the feedback, add it into the model and retrain based on the feedback. Of course, verify that the feedback is good, so the analyst will verify it again. And we are doing it all the time. And to understand that, let's talk about the numbers. We started at May 2018 with 33 customers that were willing to join our journey. Now, that means they are getting a free service for 1 year, and they need to do one thing. They need to react to us, to Checkpoint R&D, saying true or false. In some cases, by the way, we had false negatives, so that was even better. They will say, you've missed something. And then I can ask the analyst on the SOC operation that were working with me in those customers, how do you know this is a bad thing? What are the features that you have used? What is the gut hunch that you have that you thought this is bad? Now, if it's really bad, I've just got a new feature I can use. Now, the number that is bigger than that is for December 2018, 108 SOC operations. And SOC operations can be between 2 personals to much more. The size of the networks were between 2,000 endpoints to 200,000 users sitting in the same network. This is one of the biggest conglomerates in the globe that were willing not only to share data, but to be the expert that get the input, and then the output will be true or false. So we start with the numbers. The simplest numbers at the start, 1,473,000 logs were analyzed. Now, those are not the 59 million logs. Those logs are logs after a first initial analysis saying, those are bad. Now, how bad they are, or do you need to react to them? That's a different question, but those are bad. So you have almost 1.5 million logs. They are divided into 7,079 endpoints in those customers that share the data. But only 740 of them found infected. Based on the machine, the false positive rate was extremely low, 1.12 at the start. I will talk in a second about how we'll look at the data from our side, but I want to give you an example. And the example is a customer that we've sat with 1.5 years ago, I think, if I recall, and we had a training session, and we looked on a feature. The feature that we looked at is behavioral on time, and we have found a host that is starting a very suspicious communication at 6:59 at night and end this suspicious communication at 6:59 in the morning. Now, if you look on this only feature, that will be not enough. You need more context, intelligence context, of course. And one feature is not that. So we found more and more and more and more features that assisted us to say, okay, definitely bad, and definitely something that the machine caught. Now, how did she cut it? What is the measurements she took? It's machine learning, so it's not a black powder, but it's almost impossible to know in some cases. But in this case, we're able to understand there is a new feature that we need to look at, and that was good because our customers are sharing with us. Now, from the other hand, it's a one feature. And there is a full suite of solutions called UEBA, means user behavioral analysis. And I will give an example for that. My host is connecting every day to somewhere, uploading 100 gigabytes of data. Now, next week, I will upload 200 gigabytes of data. What the UBA will do, it will say, okay, I will learn for 1 week what you're doing. And on the next week, I will alert. So 200 gigabytes of data, it's 100% more, right? So what? What does it mean? Does the SOC operation need now to close everything and do something with it, or it's just another log? Because it's one feature. We took multiple features. We retrained ourselves, and based on the retraining, we've learned on more features from those SOC analysts that, by the way, until now, they are retraining us. We are getting the feedbacks all the time. As an example for the data, or this data set of the 33 customers, I want to show the following graph. In a very simple way, between 0.8 to 1, those are victims, by the way. So you have time, you have a score and victim numbers. So you see that between 0.8 to 1, those are victims that are infected based on what we've built. Between 0 to 0.2, those are not infected. And the work we have done for the last 2 years is working on the middle. And that's the important part when you address a machine learning algorithm you want to create. I know that you know that better than me. We have an unknown area. I do not know, or the machine do not know, if it's bad or if it's good based on its knowledge. So we are taking those samples one by one, tagging them, understand them, and retrain the machine. That took us 2 years almost to achieve, to clean the middle, to have between 0.8 to 1 and 0 to 1.2. Now, everything is data set. We understand that we have the knowledge, expertise, customers, but data is the most important part, and big data is the most important part. Threat Cloud in Checkpoint is our repository, intelligence repository. That means we have all of the indicators, all of the connections, all of the data we need, or we want, or we will want. We have in the same big data repository. Now that means that we now have enough data set to locate the next thing we want to do. And Checkpoint allowed us inside R&D to achieve something, to create something new, because we have the data, expertise, customers that were willing to work with us, and enough time. 2.5 years of the time of a retraining to get into a position when, if you go to Infinity SOC now and just Google it, and you go to the demo, you onboard yourself, it's extremely simple, you get the precision you need as a SOC operator, because those are the customers of Infinity SOC. I want to conclude with the important part of understanding that you know better than me it's hard. To create a real machine learning algorithm that locates something, you need to tag the data in this case. You need to be able to be certain. You need to retrain the machine based on other experts, and you need lots and lots of data set. So we've done that. We've implemented it into a product. And the most important part when coming to a problem like that, or to a machine learning challenge, is to understand the need from the customer. Because if we will solve even a niche that will solve something for the customer, we have the product. And that's what we've done. Checkpoint also are in the exhibition room. You're welcome to join us in the exhibition room, in the 2 rooms that we have, and speak with our representatives. We will gladly show you all of the content of all of Checkpoint products, of course, and Infinity SOC specifically. Thank you very much.